Thank you for this wonderful welcome. I'm so happy to be here again after such a long time, because last year I couldn't attend. And wow, there are people up there as well. Hoo-hoo. So, yeah, some of you might know me. I have spoken on DDD Europe last time, I think 2019, and I want to show you what we have done since. I don't know if this means something for you, but I finished my university time in 1995, so it's quite a while ago. In 2004, I was already working in a company programming software, actually in my company, the WPS company, which is up there with the booth. And we read the book of Eric Evans in 2004, and we really fell in love with it, this idea of following the domain. And since then, we have programmed software like that. And we started with 12 people, and these days we are 170 people, as you can see here. And we create all kinds of software, and we really love to do it with domain-driven design, with all these ideas about tactical and strategic design. And in the beginning, we did it ourselves for our own software development. And after a while, we realized, like around 2012, when microservices came around, and you probably started to hear about domain-driven design as well, we started to help other people with their software systems. And a while later, we started to write books about them, about all this, and I'm going to start with this because what I'm talking to you about today is the result of all these books. So I started in 2015 with the German version. Of the English version came in 2019 about sustainable software architecture, and in that book I talk about technical depth, how to analyze them, reduce them, and DDD is then in there a bit as well. And this is why they asked us, Henning and me, to translate the book of von Vernon, Domain-Driven Design, distilled into German, which we did, which was a lot of fun, and at that time easier than to write our own book, actually. And then Henning and Stefan came around and wrote the book about domain storytelling. Some of you were in the workshop on Tuesday, I think. Yeah, Tuesday it was. And finally, last year, 2023, Henning and I took all this together and wrote a new book, which we call Domain-Driven Transformation. And unfortunately, I only have the English cover, and I can't give you the book because it takes time to get a book through the review process and everything. But Rebecca did a review on our book, and I mean, if you ever want a good review for your book, ask Rebecca to do it, because it was amazing what she had to tell us, and the whole book got much better. So the English version will be better than the German one anyway. And it's all because of Rebecca. It gave us such a good feedback. Why did we write this book? Well, we wrote this book because we have been doing a lot of consulting with domain-driven design over the years, and some other techniques that are in these other books. And the main situation of our customers when we get there looks like this. They have a legacy system, so this is normally the case. They call us, Henning, Carola, can you come and help us? We have this legacy system, and it's so expensive, and we don't get forward. We can't put anything in there. And then I asked them, well, what do you have? And then they say, well, we have 3 million of Java. And I say, yes, this is a lot, but there are other companies that have 3 million lines of code in Java. And then I asked them, how many people are working on that stuff? And they say, well, we have 30 developers. And I say, yeah, okay, 30 developers. And, well, what is the problem? Well, the problem is we can't build anything new again. All these 30 people have to do bug fixing, maintenance, and so on. And then I tell them, well, this is really a problem, you know? For 3 million lines of code, you should have something like 12 people dealing with the maintenance, but not 30. This is too much. There is really a problem. And the problem inside of the software generally looks like this. You know, what is this? These are 463 classes. Each of the rectangles is a class, actually, and we took this system into an analysis tool, and it created this diagram, and we asked them, well, which classes belong to which component, and these are the colors. So all the green ones belong together, but yeah, you see they are shattered everywhere around, and the dark arrows there, those are the relationships between all these classes. And you can see that in the middle there's a lot of that. You know, it's almost dark there because there are so many relationships. And this is what we find in software systems, and you all know how we call it in domain-driven design. This is a big ball of mud, really. So this is what we see with our customers. And the question is then, well, what should we do? What should we do, Carola? How can we, you know, how can we live with that for a long time? Do we get it apart? What are we doing? And this is where we started, Henning and I, to form our own method and call it domain-driven transformation. So it's about getting a big ball of mud into a modular architecture, something that has clear boundaries, clear interfaces, where cohesion is high and there is loose coupling. This is the important and basic message. Whatever you go off with high cohesion and loose coupling. I really don't know why this happened, that we have such a strong coupling in whatever system we come around. Don't do it, okay? Please, stop coupling, okay? And what we are doing basically is we define four steps that we take when we do domain-driven transformation. First step is rediscover the domain. I'm going to show you later how to do that with an example. The second step is determine the target architecture from the domain rediscovery, and then compare the actual architecture that is programmed into your system with this target architecture. And the fourth step, of course, is do it, you know, just change your system towards this new architecture, which is difficult enough, of course. And the people ask me if when I'm helping them, how much will this cost? And the answer is I actually don't know, because you spend 10 years, 15 years, 20 years to create this horrible thingamabob here, and it will take some time to get it apart, you know? This is for sure. And we're going to look at a little example. I choose a domain, I don't know if you know it, but it's the leasing domain. So there are three roles in this domain. There is the customer who want to lease a car, who want to have a car. There is the salesperson, and there is a risk manager. And I choose domain storytelling to show you this domain rediscovery. So the customer tells the salesperson that he wants a car. I want a car like this and that. And the salesperson looks for cars and then calculates the installment for a contract. The customer signs the contract. The risk manager gets the contract handed over because he has to check the credit rate. This is, in Germany, this is done like that. You have to have 4 eyes that look at the contract like that. And then he calculates the real sale, and he votes the contract, and then the customer can have his car. So, of course, I know that the real process is much more complicated than that. If you ever asked for a leasing car, you know that. But on a slide, we have to reduce ourselves. Okay? So, of course, these rediscoveries with customers, they get much more, much bigger, and we have several of these domain stories. But we do this normally in little workshops, like with some domain experts, 2 hours, and we have a good understanding of how the domain was organized. And now the moment comes that we try to find out how could we cut this domain story into into good subdomains, into something that would help us to arrive at a context map. So we start and find two subdomains here. On the left side, the sales, and on the right side, the risk management. Different people doing different kinds of work. How you really find those subdomains, this is a whole talk on its own, so I'm not going to go into details, just accept it for the moment. And, well, we have found these two first subdomains, and this is always a good starting point to discuss with the customers, with the domain experts, and you will probably find some more price calculation, maybe risk reporting, payment, all this. And then you have a basis to create a context map. I just reduced it to three subdomains again, and then you can talk about the relationships between these different subdomains. Are they customer and supplier? Is there a conformist in there? Who is downstream? Who's upstream? And when you have discussed all this, you really have a first idea of the target architecture. This is where you are heading to, and this is the moment where we start to look at the old system. And, well, often we find modules in old systems. People have an idea of a higher structure than classes and packages, and this is a good thing. But if you put them onto each other, you see that this does not work. They don't fit together, you know? And people ask us, how good or how bad are we? Carola, how are we? And the thing that we did is in these analysis workshops, when we do this with them together, finally we give them a grade, actually. And we called this thing Modularity Maturity Index. There is, I'm going to explain everything, but we start on the left side. If you have a very bad system, a big ball of mud, you will end up with a grade between 0 and 4. If you're mediocre, so it's okay, but not really good, you're between 4 and 8. And if you're really, really, really good, you're between 8 and 10. And what you see here are the results of 21 systems that we have measured, actually, one after the other. So we started on the left side. It's just the time on that axis. And the size of the bubbles shows the size of the system. So we actually saw a very good one that almost has 15 million lines of code, a really good system, a Java system. But I'm sorry, the one down there is a Java system as well. And the other big one up there, which is pretty good, is a C# system that we found in Romania. Are there some Romanian people here? I don't know. But anyway, a really impressive C# system. So in there, all kinds of languages, C++, PHP, JavaScript, whatever you want. It does not depend on the language that you're using. It depends on what we are measuring about modularity. And how do we do it? Well, these days we do this in a remote session, and we use all kinds of tools to measure several indicators that tell us, is this system really modular? And I already spoke about one thing that is in a lot of our measures, the coupling. You know, I told you, don't couple your software. And this is one of the measures that we look at. We look at modularity, we look at hierarchies, we look at how many patterns do they use, because patterns are really a good idea to create modular software. And if you want to know how to measure this index, there are books where it's inside. There's the one which is available already, the Software Architecture Metrics book, and the other one, I hope it will come out. But what are we doing with this measure? Well, I'm going to show you how a real perfect architecture would look like in the Modularity Maturity Index. A really good architecture would look like this. You would have modules really separated from each other with a nice layering inside and with very little coupling in between. And that's the point. Loose coupling doesn't mean that you use some specific technical framework to send a bunch of events all over the place. Loose coupling means as little coupling as possible. That's the point, okay? And, when you look at systems of on these different levels and these different numbers, normally down there is the big ball of mud, always. Those systems in general have at least a technical layering, but that is all. They don't have modules like in the domain-driven design idea, and then those up there, they are really done with an idea of the domain behind them. And well, most of our customers, they want to get up, you know, from down there, up there. So that's where they want to go. And I'm going to show you what we tell them to do, you know, because I don't have like a secret special medicine to give to the software system, and then it will be in a good shape. The work has to be done. So for the big ball of mud, the idea is actually to start with something that we call technical domain-driven transformation. What you really have to do with these systems normally is make them stable on a technical level. Very often when we see systems that are a big ball of mud, we have to deal with teams that tell us, oh, last night I had to get up at 3 o'clock and restart the server and things like that, you know? So really they are technically not stable at all, and you can't start with cutting them into modules. Then their architecture normally looks like this, you know? Everything knows everything everywhere, every relation is going around and around and around. And of course only one database. So what we try to tell them is start down there. Start with automate your build and deployment, update your frameworks, improve your error resilience, and do some tests. I hope you all have automated tests. I always ask them when I call them, are you doing testing? I mean automated testing? And then if they say, you mean unit tests? Yes, I say. How many percentage do you have? Oh, 10%? And then I know what is waiting for me, you know? Something horrible, yeah. And can't tell them to cut it into pieces, you know? I mean, this is more dangerous than anything. So they have to do something to increase security, infrastructure, and to have less bugs. Of course, I'm not standing here and telling you to test everything. I know this is impossible, but do it step by step. Whenever you touch any part of your software system, write a test for that, what you're doing there. So you make it better, okay? And then when this is done, and the funny thing about that is, this is a low-hanging fruit, because normally this is done quickly. An update, automation of the building pipeline and all that, this is okay. You can do that if there are some intelligent people around. Otherwise, you need someone from outside. But then you have to go a step further, and then you have to do something about the design. If the design is horrible in a big ball of mud, what does this mean? You have these cycles, you don't know where to change something. If people, the other day someone told me, well, if there is a bug, we debug it, and then when we find the thing where it is, well, we just try to do something, we throw an exception and try to catch it somewhere, and then we hope that it's done. Yeah, okay. Horrible stories, of course. So what do you have to do here? And you heard about that yesterday. People who have been there heard about that in Dora's talk as well. You have to do something. You have to enrich the domain model. You have to start to use value objects. You have to introduce design by contract and get rid of cycles and reduce inheritance. I mean, it's really frustrating the amount of inheritance that we find in old systems. Just don't do it. It's the strongest form of coupling ever if a class inherits from another one. You will never get them apart again. So just only do it if you're really sure that this is a good idea. Okay? So design gets better. This is what you have to do if you have a big ball of mud. If you are in the middle, there are two ways. There are systems that need, in the first place, a strengthening of the domain before you can cut them apart. And then there are others that you can cut apart first and then strengthen the domain. And I will show you how they look like. Path one, where you have to start on the design level, looks like this. There is some kind of cut of modules, but there is one big domain model. The first thing that I look at when I start an analysis of a legacy system is, where are the big classes? Where are the huge classes? And if they are in the domain model, I know that it's this, you know? Because someone built the customer class. And then the next person came, and they taught us to do reuse. So this person takes the customer class and enhances with his methods, you know? And then the next one comes, and the customer class grows and grows. And, well, I'm from Hamburg, and we have a huge harbor in Hamburg. And I brought you an example from the harbor of Hamburg to show you what kind of systems normally end up like this. So if you ever get to Hamburg, go and look at the harbor, because it's organized like this. There are the container vessels that arrive in the harbor, and that they get attached on the quay. And then there is a crane that takes the containers off the ship and puts them on automated guided vehicles. So this is all automated already since 10 years. There's no one there, no person, only on the crane, one person on the crane, getting off the containers, because this is something humans do better than computers. But the rest, all done by computers. And then the container is transported to this rail mount gantry crane, and they put it into the yard, stock it somewhere, and then there comes a truck to take them away, or there comes a train. And I hope you heard what I was talking about. There was the container everywhere. And in this system, for a terminal like that, of course, there is a huge container class where you can register the container before they arrive, the truck or the train or the vessel, where you put down the data for loading and unloading from the container vessel, where you put in the unloading and loading from the truck, the customer clearance, and everything else, and as well the storage and the transfer. So everything is stored in this one container class, and you end up with a system like this. Everybody is using the container class. So if you have a domain where there is this central domain object, then you will end up like this. Funnily enough, in banks, it's often not the case. I don't know if you have online banking, but probably you know this. You're in your account, you're looking for money and whatever, and then you want to have a look for securities or for credit or whatever, and you get into another system. So in banks, they have so specific work objects or domain models that you already in the systems today, you see that they have several different systems. They are lucky. But if you have this, and yeah, from a domain-driven design point of view, they are lucky. And if you look with a tool at systems like this, you will find something like that. I'm going to explain to you what you see. This is a diagram from a tool that you can use to analyze architecture. And what you see here is the model that we put onto the source code already. So what's happening? The tool analyzes the source code and gets out the structure, all the classes, all the packages, who is using whom. And if you click on the plus in front of mailing, import, export, or whatever, it will open and you will see the package tree and the classes in there. So we put these rectangles there and we said this package tree belongs to mailing and so on. And on the right side, you see these arcs. And these arcs are the relationships that exist in this source code. So you can see, I have a look if this works here. Yeah. Up here, mailing is using import, export. On the left side, the relationship is going downwards, and on the right side, it's going upwards. The colors are not important here. Green or red is not, red is not horrible, it's just there, okay? So when we looked at it, we said, oh, maybe those three here could be one bounded context, maybe. No? They use each other, but there's a cut. Yeah? And, well, we were going on and looking at all that, all kinds of use cases that they programmed into their system, and then we got to something that was called model. And I said, oh, what is this, dear architect? Didn't you tell me that your system was organized via use cases? And he said, yes, but you know, the first use case had some domain model classes, and then the next one came and he reused it. Okay, I said, well, listen, if you want to cut your system into, bounded context, we have to get rid of that, Could we maybe move the classes upwards, towards where they belong, maybe? Yeah, he said, we could try. I said, okay. And then we opened the model part and took the classes and moved them. In good architecture analysis tools, you can do that. You can just try out what will happen if you change it. We didn't do many, but I think we did 20%. And then it looked like this. And this is, you see all the arcs that appear, all the relationships. We just moved some classes. The darker a rectangle is, the more is in there. And you can see, I hope, that improvement is darker than before. There is more in there. And in reporting as well, more than before. But model is still really full. But we moved a lot of model classes up there, and the tanglement is in the model, Where we actually want to head to, we want a structure like this, with smaller container classes, each of them in one of the bounded contexts. So if you have this situation with one big container class, then the only thing you can do is you have to start and do something about the design. What I told you before, enrich the domain model, use value objects, and all that. So you get to a better design, and then you can actually start cutting your system into pieces with the 4 steps that I talked to you about before. If you are lucky, you might have a system like this. This is as well a system between 4 and 8, but the domain model is divided already. This is the bank, so to speak. In this case, even if the design is bad, you can start on the top level and cut the system into bounded contexts. You can do that. And afterwards, go for the design. Yeah? If you are really, 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 really lucky, all of you, of course, create wonderful software. No? You're between 8 and 10, and then you can just do the last step that I have been showing you. You can just cut the thing into pieces with domain-driven transformation. Okay. Henning and I are doing this, other colleagues as well, with our customers. And while doing this, we saw that sometimes it's easy to cut a domain into bounded context, and sometimes it's really hard. And we have to discuss for hours. And sometimes we even don't know, even if this is a huge system. And this is what I want to spend the rest of the time with. we tried to find some abstractions of what we saw there, and we called it domain patterns. What we found, this is just the first try, but I'm going to explain to you what I think about that and what this means. So we named them pipeline domain, blackboard domain, and dialogue domain. And I will explain you now what this means and what the idea behind this is. But one spoiler before, of course, you will not have a huge domain that has only one domain pattern. Of course, there is a subdomain in there where you probably find a blackboard and another one with a pipeline domain, okay? I'm just gonna try to explain the concept to you, and then you know, well, they can be inside of each other. No? So what is the idea of a pipeline domain? A pipeline domain, as you can see on the picture up there is one role per step. You have a one-to-one relationship in general of the role and the working object. So you as a customer in the Amazon front end, you are filling your cart with all the products you want, and then you pay, and then it goes on to the where the goods are packed. There's another person. So there is a step-by-step logic behind the processes that you discover with domain storytelling, event storming, whatever collaborative modeling you use. And there is a chronicle order, so there is the first one, the second one, and there is a very clear transition. So someone has to finish something and then hand over this work object, and the next role will do its work based on this work object that they get from the person before. Simple examples, you all know logistic processes are like this. If you purchase, deliver, process, trading on trading platforms, all this works like that. In many banks and insurances, processes work like this. The customer has to sign the contract, and then the contract is put into the system, and then he gets this and that and that. So there's a clear order of these steps. Or if you look into administration, a lot of regulation processes are as well done like that. And if you have a domain or a subdomain that is organized like this, it's quite easy to cut it, because you just do it like this. Very easy. And this is why on conferences, the examples are generally pipeline domains, because this is easy. This fits on a slide. Yeah. Blackboard domains are really nasty. You have different roles that work together on one or more intertwined objects, and there is no one-to-one relationship. Everyone is, I work on it, then you, then I. No handover of work results, no clear order of the steps. Examples for that, I have seen software that for the calculation of how to build a car or a machine or a huge technical facility. You know, you have to plan that before. And these software systems are used to do the planning. And if someone changes just one bit somewhere, everything else is changing, but you don't hand it over. Everybody is working on that, you know. Or if you're sitting in a control center and you're monitoring a container terminal, logistic processes, whatever, supply chains, you're observing and you're waiting for something, that something happens, and then you do something. So there is no real order in what you do. You're just fire pissing in the end, you know, you're just repairing. We are at the moment building the new software for the huge film festival in Berlin, the Berlinale, that was in February. Maybe you have heard about that. And this is incredible, unbelievable. You know, they organize who is sitting where from the moment that they sell the tickets to not everybody, but some people, until the moment when the people arrive. Because behind the important people, like Mark Scorsese, whoever was there this year, there should not be an empty place. You know, never ever. So you have to resolve the problems until the end. Nobody did it here, by the way. I mean, but I'm the only one with a camera in the face, so no problem. So this is absolutely Blackboard, and actually programming in an agile team is a kind of Blackboard as well, because everybody is working on the same source code. Of course, there are other parts of your work that are pipeline, but the work on the source code. Or there are a lot of computer games that are like that. Many players, they meet in a world, everybody's doing something, there's no plan, you know? So, what do we do with that? Well, I don't know. I hope someone will sometimes tell me, you know? I really don't know. We try everything, but the only way that we can go today is that we try to find out if this Blackboard domain could maybe move towards a dialogue domain. Because a dialogue domain is quite similar to a Blackboard domain. There are different roles that work together on one or more work objects, and no direct relationship between work objects and people. No real handover of work, but there is a negotiation of a plan. And this is something that we find often between several companies. So there is no boss, you know, who can say we do it like this, but they have to cooperate. And I will show you some examples for that. We are at the moment building the software for the vessels on the Rhine River. It comes into the Northern Sea somewhere here in the Netherlands, I think. And there is a negotiation between the ship companies and the ports to discuss the schedule. And nobody can decide. They just have to negotiate and hand over information, and then together they will decide something. So this domain functions like that in that part where there is the negotiation. If you think about major equipment, there is often a negotiation between the dispatchers and the customers to do maintenance cycles and all that. In Hamburg and in some other cities, we have created a software to organize the construction work on the streets and to negotiate the plan, you know. In Hamburg, it works pretty well. If you have a lot of construction work in your city, ask them if they have the right system. Anyway, and some games work like that. You know, there are games with negotiation processes inside, computer games. And these domains, we found a solution to cut them, and we have to do it by negotiation step. Yeah? Several negotiation steps together. So you can't cut them by role or by entity or by domain model or something. And I will show you an example for this. And the interesting thing is that domains, they change as well. You know, they change because there is all of a sudden software. You know, in Hamburg, we programmed a solution for the town and for all the companies in Hamburg, like the water pipe company, the company who's doing who's getting all the lanes into the road, so that we have energy in our house, and the gas pipes and whatever. You know, everybody who is digging into our streets, they all work with this system. And they all put their data in. And then they meet every now and then, like every 2 weeks, they meet around this table and they discuss the roadworks that they're going to do, you know, to ease the planning. And the interesting thing about this system is the combination of time and map, you know, the location and the time, because this is always the problem. If you just have a map and an Excel sheet, you know, it's very hard to get this together. And when we started this project, they were meeting twice a year and trying to do some Excel map thingamy-bob, and they ended always up with some kind of plan that didn't work. So in front of my house one day, they did a new cover of the street, and the next day they opened it to put in some new telephone lines, and then they closed it again, and the next day, you know that problem. They asked us to build them a system that they could better coordinate. And we discussed with them how they're going to work, and it was really blackboard. They wanted everybody to put the data in so that at least everybody could see the data. This was the first step, and we did that. We programmed a system for them where everybody could decide if they wanted to give their data to everybody, and then they could see the other data as well. So Hamburg water pipes could see the plan of the administration, and the telephone guys could see as well the plan, and then they could align with. So in the beginning, this system was a blackboard, was organized following a blackboard domain. And then all of a sudden, they came and they said, wow, it's wonderful. We see everything. We can coordinate now, but it's a bit chaotic. And we said, yes, we understand. So can we have some process in there with a negotiation? And we said, yes, of course. And we said, well, it will take half a year to program that. And they said, oh, shit, because we want to start now. Yeah? So in the first place, the software helped them to get into their ideas, and then it took a time for the software to follow. But today, they have a blackboard domain. They are doing this in a blackboard, in a dialogue manner, so they have a dialogue domain. Their blackboard has evolved. And from this software where they were all doing their stuff, now they have something that is following a plan in the end. So their software system moved, and the domain moved, and they both interacted with each other to change the world. So, and I hope I came across with this idea that probably you have a domain for one system, several systems, and in this domain there are subdomains. And in one subdomain, there are again subdomains. And, well, maybe you have a pipeline on the topmost domain. Possible. And maybe you have a subdomain that is a pipeline. But you probably have a dialogue somewhere, and you probably have some blackboard as well, and maybe in there is a pipeline again. So this is all one inside the other, and actually it depends. If they ask us to look with them at the domain, the whole domain, and we find a pipeline, it will be easy, But if somebody asks us to come and look at that one, at the blackboard, well, it will be difficult, and we will have to discuss it. And I hope that in my talk here, you have understood something about domain-driven transformation. I showed you different ways what to do with your software, and you have seen our first ideas about pipeline domain, dialogue domain, and blackboard domain. And if you have further questions, you find us on the first floor. Thank you. We have still some time for questions and this wonderful thing to throw around.
We do. We have the cube of questions, and I see hands going up. Great.
Yeah.
I think that hand went up first. Yes.
Hello. Fantastic talk. Really enjoyed that. Just wanted to ask if you've discovered any other types of domain patterns.
Not on this high level. Something was a bit hidden in there. I talked about the domains with one huge domain model. You can talk about that as a pattern too. And in the book there is something about formula-based domain models, because I don't know if you can relate to that, but often in administrations you find already paper formula, and you have to fill that in. And actually, this is already a model of something. And then people create this formula in the software, so you create a model of a model of something, you know? And maybe this is not the best idea because you really want to model the real thing in your software. So there are ideas like this. But on the high level, this is what we found. And if anybody has something else, I would love to discuss it, of course. Yeah.
Thank you very much.
Oh, I didn't count the
You
the
can
hands.
throw over here.
Well, basketball.
Thanks for the great talk. For the first step of transformation,
Yeah.
you said we need to discover.
Yeah.
So sometimes the knowledge around the domain, we do not have a single source of truth. Multiple people know about that.
Yes.
And we had the same situation in our company. We decided to discover our legacy system. And we didn't know which tool can we use. We tried event storming and it doesn't work.
Yeah.
For new services, it works well, but
I
actually we
understand.
couldn't. What do you suggest for that?
Well, I'm a big fan, as you saw, of domain storytelling because people see themselves. You know, this picture with the actors, with the customer and the bank, the leasing salesperson. You know, when we do this, we do it really in workshops with different people from different departments who know about the domain, their little part of the domain. And we take them together in a workshop and we say, well, we just want to understand the big picture from left to right. You know, what are you doing here? How is your business going? How are you earning money? You know, and then we start somewhere, like the salesperson maybe, telling us, well, I'm the first one, and I do this. And then you see what he's throwing over, handing over to someone else. And you have to try to get to the domain level. But in the beginning, often you have systems in there, you know, people have difficulties to get back to the real domain language or domain concepts, you know. So then you have the SIP system in there, and you have this system and that system. But by the time you get rid of them, you know, it's just needs some time. But there are other collaborative modeling techniques. On our booth, we have a little card for the Como Camp, which is an unconference that we support every year in Vienna, where people discuss all these possibilities to discuss with the customer. But maybe the domain storytelling is already a help.
Many thanks.
Yeah.
Right. More questions? Can you throw the cube over there?
Over there. There. Oh, over there. Well, tough. Anyway.
Hi.
Hi.
Thank you for this lightning talk. I wonder, you mentioned about the code coverage before we start the transformation.
Yeah.
I wonder if there's a good amount of code coverage before we start.
You mean
what is the number?
like tests?
Yes, for the tests.
Okay. This is a very difficult question because it depends really on the possibility and the money of the company, you know. The other day, a client called us and he said, well, we need your help. Well, I know that, you know, and then I said, yes, what is your problem? Well, we have a legacy system and we have to divide it into, we want to, you know, get the modularity better and everything, the design. And I said, okay, tell me something about the history of the system. And they said, well, it was built by another company, but it was really horrible. We had problems all the time, breakdowns, bugs, nothing. So we took it back in. And we said, well, we will just do some repairment, less bugs, and then we will start from scratch, you know, and have a new system, and we all will have fun. But then they did like 4 years of bugs fixing, test programming, and then the customer said, oh, the system is really wonderful. Can't we stick with it? You know, do we really need something new? So it's really a question of time and money you have, you know. In my company, for the domain parts of the software, 80% is the minimum.
Thank you.
If you ever try to get a new job, ask them about the test coverage.
Okay, we can take one more question.
And afterwards, you can find me at the booth up there.
You can relay the cube like that way. There's two people with their hands up over there.
You can find me up there in the booth, you know?
Yes, you can find Carola around the conference.
Yeah. But I will go tonight. So you have to talk to me today if you want. So,
Hi.
Hi.
Very nice talk. Thank you for this. I was triggered a bit about the modularity maturity index. I'm wondering, very useful for analyzing one system, but do you have any advice on analyzing modularity in distributed systems?
Yes. I mean, we have customers that ask us, they don't produce software themselves, they just use it, but it's individually programmed. So they ask us to go to each of those companies and look at the system and give an individual modularity maturity index to each of these systems, and then they know where they will have to invest money, Because, I mean, I could create one modularity maturity index for the whole landscape, but it will not help them. You always have to think about the level where a number like that is really useful. So I can generate numbers for a whole landscape, but my question would be, what will you do with that,
I noticed, like, within a system, you can get very high numbers. At least it's our case. We scored around 9.3, and then we were wondering, where is the complexity? The complexity is probably in the distributed systems and in the lack of modularity there. So it's hard to apply it.
Yeah, you can do it on any level. It's not... Maybe we should talk about that in the break.
You.
Yeah, because the next one is waiting here. But it's a wonderful question.
Thank you.
So, this was it, was it?
Please give it up for Carola.